Hi, in this video we're going to look at something called partial functions. Now the idea behind partial functions is actually quite simple. It's really how can we reduce the number of required arguments when calling a function. And there's various reasons why we might want to do this that we'll get into later. But really it boils down to, is there a way that we can call a function which, let's say, has 3 arguments? So for example, let's say we have a function myfunc that has 3 mandatory positional arguments, a, b, and c. It does something with those 3 arguments. In this case, I'm just going to print them out. Can we somehow rework this so that myfunc can only take 2 parameters? In other words, we'll need to provide some kind of value, maybe a default, you can think of it as a default value, for a. Now myfunc doesn't have a default. So how can we do this? Well, pretty simply, we could do it this way. We could say def fn, so now we create a new function which takes in 2 parameters, let's say b and c, and it's going to call myfunc. It's going to return the value that's returned from myfunc when we set a equal to 10 and then b and c passed in as normal. So you can see we've reduced the number of arguments needed to call myfunc by 1, because now we've specified a value for 10. We've predetermined what that value should be. Now, of course, we could do something a little more fancy. We could maybe put an a equals 10 in here, but of course, now we can't put it in front, so we'd have to put it at the back. So we'd say b comma c comma a equals 10, and we could now call fn with just b and c, and then put a in here. We could do that. We'll see how that works actually later on using partial functions. But now if we call fn of 20 comma 30, we're going to get the output 10, 20, 30 because a was set to 10. So we've reduced the number of arguments needed to call myfunc. Now myfunc still needs 3 arguments, okay? That we can't change. But the way we call myfunc, we don't have to specify 3 arguments. Now we can just specify 2 because we've kind of preset what one of them would be. We can also use a lambda to do the same thing. So in this case, all we're going to do here is we're going to do the same thing. We're going to take in 2 arguments, and then we're going to call myfunc, and we're going to pass in 10 for a, and then the b and c arguments will get passed to the b and c arguments of myfunc. So exactly the same thing as what we did in this def here. And so the output will again be 10, 20, 30. So that's pretty standard. You can do things that way. We'll see why you may want to decrease the number of arguments and predetermine or preset what an argument might be ahead of time. But you can also do it using the partial function that's available in the functools module. So this function takes in, first parameter is the callable that you want to call. So in this case, it's myfunc, right? We want to call myfunc. And then you specify values for parameters of myfunc. In this case, I've only specified 1 in keeping with what we had over here. So this one here is a positional argument. So this is the first positional argument. It will get passed in as the first positional argument of myfunc. So now I can call f with 20 and 30. So now 20 and 30 will get passed as the second and third positional arguments, seeing that 10 over here is the first one. And it's going to call myfunc, therefore, with 10, 20, and 30. And so our output is 10, 20, 30. Same as before. So the syntax is maybe just a little simpler, a little clearer here. You don't have the lambda or a def coming in between. It's maybe more straightforward. Now you can handle more complex arguments. Let's say that we have myfunc that takes in a and b, 2 mandatory positional arguments, an arbitrary number of positional arguments, 2 keyword-only arguments, mandatory, they have no defaults, and then a variable number of keyword arguments. So here again, my function is just going to print the stuff out. So now let's say we want to reduce the number of arguments that we're sending to myfunc. So we want to be able to call myfunc, but with less arguments. That means we're going to have to provide values for those arguments that we're not going to specify. So in this case, I'm going to pick 10 for a. So the first positional argument is going to go into the first positional argument. So 10 will go into a. b, which you'll notice is the first positional argument of f, is going to be passed in as the second positional argument of myfunc. Then star args, I'm just going to take star args as is and pass it as here to basically star args as well. Next, I'm going to specify an actual value for k1. So you'll notice I'm not requesting k1 here. Okay? Instead, k1, I'm going to set it to the value of a, and I'm going to pass that value as the keyword value. And then for k2, I'm just going to get whatever the person sent in as the argument here for this k2 keyword. I'm going to pass that, and I'm going to do the same thing with the star arguments. I'm going to just pass them straight into my func. So you'll notice that what we've done here is we've reduced the need to, when we're calling my func, to specify a and k1. We've now reduced it by 2 arguments. So now if I say f equals partial, my func, 10, and k1 equals a, this will achieve the same thing. So whatever we had here will get essentially done here as well. So you can see now it's actually a little simpler now, the syntax. It's more visibly simpler than in the previous example, which was very simple. Okay. So let's take a look also when we're handling more complex arguments. Let's say we have this function here called power, which takes a base and an exponent, and it's just going to return the base to the power of the exponent. So 2 to the power of 3 or 3 to the power of 1.5, things like that. Okay. And I want to create a new function. So I'm going to use partial. It's going to create a new function. It's going to take in power as the function, the callable, and it's going to specify that the exponent is 2. Now you'll notice power is actually taking in 2 positional arguments. But of course, we can always pass arguments, even positional arguments in Python, using keyword values. In this case, I'm specifying that exponent is 2. So what I've eliminated from the call to power is the exponent. I can do the same thing with cube. We can say it's a partial of power with the exponent equal to 3. So now if we call square 5, what's happening? Well, 5 is a positional argument, and we're not specifying it with a keyword. It's just a positional argument. It's the first positional argument. It's going to get thrown to the first positional argument of power. Exponent, which is defined here, will get passed to exponent. So we've satisfied what power needs. We gave it 1 positional argument and 1 named argument, exponent, which is going to go into exponent here. So when we call square of 5, we actually get 25. And when we call cube of 5, we get 75, because it's basically predetermined that the exponent is going to be 3. Now if you want, you can also specify base equals 5. You can pass in, instead of using this as a positional argument, you can pass it in as a named argument as well. That's fine, right? Because we have this named argument followed by this named argument. So that's fine too. Now beware, because we can pass in named arguments, and because we have keyword value arguments as well in the more general cases, you have to be careful, because we could do the following. We could say square 5, or base equals 5, comma, exponent equals 3. What's happening here is that we're essentially going to override the value of exponent that's defined in cube. It will actually honor that. So when we call square, in square, so square has an exponent of 2. When we call square here, we're saying, no, make the exponent 3. So you can still override the values. And in this case, we get 75. So just be aware that you can do that. And we'll see an example of where this might actually be useful. We'll see that in the coding section. Now, one other point that you should be really careful with is when you use variables when you're creating partials. So there's a similar issue that arises to the one that we had when we were using default values for arguments. Remember that the default value for an argument was kind of fixed once the function was defined, right? Was created. Not when it was run, it was when it was created. So we have the same issue here. Let's go back to my func, 3 parameters a, b, and c. Let's say we have a equals 10, and now we say f is equal to partial of my func, comma, a. What's happening here is that the memory address that a is pointing to is baked into the partial, not the label a, right? Remember, what's getting passed in here is not the label, it's the memory address, the reference that a has. So be careful, because it's 10 really that's coded into partial, not a. So if we call 10 f of 20 comma 30, we get, as expected, 10, 20, 30. But if we now set a, let's say equal to 100, What have we done to A? Well, A is, remember, just a label. A was pointing to 10. Now A is pointing to 100. So A points to a different memory address. But the partial still points to the original object, which was 10. So if we call now F 20 and 30, do not expect to see 100, 20, 30 come through. You'll still get 10, 20, 30. So just be careful with that. It's a similar problem to what we've seen in the past. Now, if A is mutable, let's say it's a list. Let's say that A was a list, for example. Then when we call myfunc A, right? So now A is going to be a reference to that list. If I change the pointer of the list, if I change A to point to a new list, then yeah, everything will behave as I just described. But if I append something to the list, well, the memory address that A was pointing to and that partial, therefore, is using, that hasn't changed. So if you can change the contents of the object without changing the memory address reference, then you're fine. You're going to see those changes. Again, we've seen that when we were looking at argument defaults. Same thing happened there. All right, so let's switch to some code and let's see all this in action. Thanks for watching, and I'll see you in a bit.